In this session, we'll continue to look at differentiation. We'll look at some more complicated differentiation examples involving trigonometric, exponential, and logarithmic functions. So the first example we're going to look at is this. We have y equals x plus sec 2x divided by e to the 3x minus 4. Now, basically, this we should be able to recognize as basically a fraction of the form u over v. And since of that form, we can basically apply the quotient rule. According to the quotient rule, if y is equal to u over v, then it means that dy by dx is equal to v du by dx minus u dv by dx all over v squared. So in this particular case, we see that u would be equal to x plus sec 2x. Now, clearly, we're going to have to differentiate sec 2x. So we can say du by dx equals, when we differentiate x, we simply get 1. So this gives us 1 plus. Now, how do we differentiate sec 2x? Let me just drag your memory a little bit, right? The derivative of sec 2x is, right, so if you recall, when you differentiate sec x, we'd have gotten sec x tan x. But of course, here we're differentiating sec 2x. So say d by dx of sec 2x. Now, this is basically a composite trig function, a composite function in sec. So the first part of the function is to write down sec 2x tan 2x. But because it's a composite function, we have to multiply by the derivative of 2x. When we differentiate 2x, we get 2. So we can say this is times the derivative, which is d by dx of 2x. When we differentiate 2x with respect to x, we get 2. And therefore, this gives us 2 sec 2x tan 2x. Right? So the derivative of sec 2x is equal to 2 sec 2x tan 2x. So basically, this goes right here. We get that this is equal to 1 plus 2 sec 2x tan 2x. And that is, of course, the derivative of the numerator u. Let's look at the denominator now. We have v is equal to e to the 3x minus 4. And so we need to find dv by dx. So once again, just to jog your memory, generally, if we have the derivative of some exponential or some composite exponential functions, then this is simply equal to the derivative of the exponent times the function itself. So d by dx of e to the f of x is equal to f prime of x e to the f of x. So having said that, now we can basically say that dv by dx is going to be equal to the derivative of 3x minus 4, which is simply 3, and we multiply the function by it. So this is 3 e to the 3x minus 4. So therefore, the derivative of e to the 3x minus 4 is 3e to the 3x minus 4. Now, having done that now, having found dv by dx and du by dx, we can say that according to the quotient rule, right, so according to quotient rule, here we have it, dy by dx is equal to v du by dx minus u dv by dx all over v squared. So what does this give us now? This is going to give us, so let's substitute. So v is of course e to the 3x minus 4, and of course du by dx is equal to this. So therefore, what we get here is, we get e to the, let me just make some space between there. So we get dy by dx is equal to v, which is e to the 3x minus 4, times du by dx, which is 1 plus 2 sec 2x tan 2x. So this right here is the v du dx. Then we're going to subtract from that u, which is x plus sec 2x, times dv by dx, which of course is 3e to the 3x minus 4. So that's going to be times 3e to the 3x minus 4. And all of this is going to be over v squared, where v is equal to e to the 3x minus 4 all squared. So this is what that is. However, we can proceed to try to simplify the numerator a little bit. So dy by dx equals. So let's see how we can simplify the we can simplify the numerator. In the numerator, we have e to the 3x minus 4, which is multiplying this bracketed term, and then we have 3e to the 3x minus 4, which is multiplying this term. So we'll see that we can actually factor out e to the 3x minus 4. And that's going to give us 1 plus 2x sec 2x tan 2x minus 3 times this. So this is going to be equal to minus 3 sec 2x minus 3x. And this is going to be all over e to the 3x minus 4 squared. Now, given the fact that we have e to the 3x minus 4 factored out in the numerator and e to the 3x minus 4 squared in the numerator, we can do some simplification. So this will divide into itself, and this will divide into that, leaving e to the 3x minus 4. So therefore, the final answer, dy by dx, is equal to 1 plus 2x plus sec 2x tan 2x minus 3 sec 2x minus 3x all over e to the 3x minus 4. And that is the derivative, right? Now, let's try another one. Well, this one will not be a combination of exponential functions, but basically a combination of trigonometric functions. Let's look at this one. Suppose you have this one. Y equals sine cube x plus tan squared x. Now, for the purpose of differentiating, let's write these as y equals sine x cubed plus tan x all squared, which is essentially the same thing. It's just more common to see it written like this. Alright, so let's proceed. So this is not a product or a quotient, so we won't need to apply the product rule or the quotient rule, but however, we have the sine of a function raised to a particular power, or sine x raised to a particular power, and we have tan x raised to a particular power, which basically means that we'd have to apply the chain rule. But at this level, we're going to use let's apply the chain rule the quicker way. So here we go. So we say dy by dx. Now, if you want to differentiate sine x to the power of 3, the first we do is to bring the power down and multiply by it. We put back sine x inside the brackets, and we reduce the power by 1 to give us 2. But because it's a composite function, we have to multiply by the derivative of what is inside the brackets, which of course is sine x. Right? So this little piece takes care of sine x cubed. So once again, we bring the 3 down, multiply by it, put back the sine x inside the brackets, reduce the power by 1 to 2, but because it's composite, a function of a function, we have to multiply by the derivative of what is inside, which is sine x. So we multiply by the derivative of sine x. Then we go over now to the tan x term. So this is going to become now plus. Similarly, we bring the 2 down, then of course we put back the tan x, reduce the power by 1, then of course because it's a composite function, we then multiply by the derivative of tan x. And so this becomes, or this gives us dy by dx equals, so when you differentiate sine x, we get cos x. So this first part becomes 3 cos x sine squared x. So now we can actually write it in the regular format, right? Just 3 cos x sine squared x plus, and this of course going to be 2. Now when we, well, let's write 2 tan x. When we differentiate tan x, we get sec squared x, and therefore this is the derivative. So if y is equal to sine cube x plus tan squared x, the derivative dy by dx is equal to 3 cos x sine squared x plus 2 tan x sec squared x. Right, we'll try another one. Suppose we have let's look at this one. This one is this also comprises of functions over functions, or composite trig functions. So we have y equals cos cube 2x divided by sine squared x. Again, we should be able to recognize this as a fraction, which is basically of the form u over v. So if y is equal to u over v, then this means that by the quotient rule, dy by dx is equal to v du by dx minus u dv by dx all over v squared. Right? So this we say let u is equal to, this is basically cos 2x cubed. So this is basically cos of 2x cubed, which therefore means that du by dx will be equal to, what's the first thing we do? We bring the 3 down and multiply by it. This is 3. We put back cos 2x inside the brackets, and we reduce the power by 1 to give us cos 2x squared. But because this is a composite trig function, we have to multiply by the derivative of cos 2x. So this is going to give us 3 cos squared 2x times. Now when we differentiate cos, we get minus sine. So this is going to, first part of this is going to be minus sine 2x. But cos 2x is itself a composite function, and now we have to multiply by the derivative of 2x. So this is basically going to give us, now the derivative of 2x is simply equal to 2. So this little piece right here is equal to 2. So we're just going to multiply this by 2, and overall we get 236, and the minus sign is going to give us minus 6 sine 2x cos squared 2x. And that is the derivative of cos cubed 2x. So once again, we wrote it as cos 2x cubed, and we applied the chain rule. We brought the 3 down, kept the cos 2x, reduced the power by 1, then multiplied by the derivative of cos 2x. So in the next line, we get 3 cos squared 2x. The derivative of cos 2x involves first differentiating cosine to give you negative sine. So the first part there is negative sine 2x, but this is also composite, so you have to multiply by the derivative of 2x, which of course is equal to 2. So this becomes 2 3s are 6, and the minus gives us minus 6 sine 2x cos squared 2x. So that was the u. Now let's look at the v. So now we say that v is equal to sine x squared. We write it like that for simplicity. And this therefore means that dv by dx is equal to 2 sine x times the derivative of sine x, which is cos x. So this is simply equal to 2 sine x cos x. And then now by the chain rule, dy by dx, we say that dy by dx equals, so again we're using this, not the chain rule but the quotient rule. So according to the quotient rule, dy by dx is equal to v du by dx minus u dv by dx all over v squared. So let's just draw the line. So v is sine squared x, so this is sine squared x times du by dx, which of course is negative 6 sine 2x cos squared 2x minus u, which is what is u again? U is cos cubed 2x. This is cos cubed 2x, and then that u is being multiplied by dv by dx. So this is times dv by dx, which of course is 2 sine x cos x, and this is all over v squared, which is sine squared x squared. Right? Now, is there much simplification that we can do to this? Probably not. So we're just gonna write it back. But if there's any simplification to be made, we'll check. So therefore, dy by dx is equal to, so this basically gives us negative 6 sine 2x sine squared x cos squared 2x minus 2 sine x cos x cos cubed 2x all over sine to the fourth x. So in the numerator, of course, we have, let's see what's common. We have, is sine 2x common? No, it is not. Is sine x common to both terms? No, it is not. So there's not much we can do in terms of simplification. But of course, we have sine x and we have sine squared x. We could actually factorize, but it wouldn't help much. So we'll just leave it exactly as it is, right? So this is dy by dx equals negative 6 sine 2x sine squared x cos squared 2x minus 2 sine x cos cubed 2x all over sine to the fourth power of x, or sine of x to the fourth power. Right? Let's do another one. Now, this one says y equals not e yet, but y equals x plus, no, I think I already did that. Or did I? Yes, I already did that one. Alright, let's do another one. Erase this. So this time it is y equals 3 to the minus x times the natural log of x squared. So here we have y equals 3 to the minus x times the natural log of x squared. Now, this first part, of course, this is of the form y equals uv. And of course, which means that we're going to have to apply the product rule. So therefore, dy by dx is equal to u dv by dx plus v du by dx. Right? Now, basically, we see that u would be equal to 3 to the minus x. Now, how exactly do we differentiate something like this? To differentiate something like this, which is basically an exponential function, we first take logs. We first take natural logs of both sides. So taking natural log of both sides, see that natural log of u is equal to natural log of 3 to the minus x. From the laws of logarithm, when you take the log of something raised to a power, you can bring the power down and multiply by it. So we get natural log of u is equal to minus x times the natural log of 3, minus x ln 3. And then we basically say that we're going to differentiate both sides now with respect to x, right? So we're going to differentiate both sides with respect to x. So we're going to say that d by dx of the natural log of u is equal to d by dx of minus x times natural log of 3. Now, this is basically going to give us 1 over u du by dx, and this is going to give us the natural log of 3 is basically a multiplying constant, so we can keep that outside. This is natural log of 3, and then times, when you differentiate minus x with respect to x, you basically get negative 1, right? You get negative 1. So therefore, what this means is that, let me just draw a line right here and continue over here. It means that 1 over u du by dx, sorry, that is du. The 1 over u du by dx is equal to minus natural log of 3, which basically means that du by dx is equal to minus u times the natural log of 3. But of course, if you recall, u is equal to 3 to the minus x, right? So u is equal to 3 to the minus x. So therefore, this becomes du by dx is equal to negative 3 to the minus x times the natural log of 3, right? Or we can basically write it as, yeah, let's leave it as that. Minus 3 to the minus x times the natural log of 3. That is du by dx. So of course, now we need to work out the derivative of v. So say that v is equal to the natural log of x squared. Now, if you recall, whenever we have the natural log of some function of x, if we say that y equals the natural log of some function f of x, then it means that dy by dx is simply going to be equal to the derivative of the function divided by the function itself. And so basically, what this is going to give us is that dv by dx equals, now in this particular case, the function f of x is equal to x squared. So it's simply going to be the derivative of x squared, which is 2x divided by x squared. And of course, that gives us 2 over x. So having found du by dx and dv by dx, we can say by the product rule, dy by dx is equal to u dv by dx plus v times du by dx. And so this means that dy by dx is equal to u, which is 3 to the minus x, times dv by dx, which is 2 over x, plus v, which is the natural log of x squared, times du by dx, which of course is negative 3 to the minus x, times the natural log of 3. We could leave it like that. Yes, we can. I mean, there's no point in actually trying to simplifying something like that. But let's see what we can do further. So this is basically the same thing as 2 times 3 to the minus x over x, right? Plus, or well, that's going to be negative because the minus sign there make it negative. That's going to be equal to minus, let me see now, natural log of 3 times 3 to the minus x times the natural log of x squared, right? And that is it. So, well, that is it. We could leave it like that. There's no need to actually carry out any further factorization. We could leave it like that, right? So therefore, the derivative of 3 to the minus x times natural log of x squared is equal to 2 times 3 to the minus x over x minus natural log of 3 times 3 to the minus x times natural log of x squared. But if we want to simplify that by factoring out, we could actually factor out 3 to the minus x. So we could factor out 3 to the minus x, and that's going to leave in brackets 2 over x minus the natural log of 3 times the natural log of x squared. And that's it.